In December 2004, scientists stumbled upon an asteroid known as Apus, named after the ancient Egyptian god associated with death and darkness. Picture this. Eons ago, a celestial wanderer hurtled through the vastness of space, colliding with our planet. The aftermath? A cataclysmic event that wiped out more than 70% of life on Earth, sealing the fate of the dinosaurs. Fast forward to today, and the renowned astrophysicist Neil deGrasse Tyson is raising eyebrows with a chilling prediction. He foresees another asteroid making contact with Earth in the coming years, with potentially devastating consequences. But how exactly do astronomers track these wandering behemoths? What could be the implications of this celestial collision, and what measures are in place to safeguard our planet from such cosmic threats? Join us as we unravel how NASA's satellite just detected something massive between Earth and planet Venus, our solar system and its history of violent collisions. In the vast history of our solar system, there have been numerous violent clashes between celestial bodies. A cursory gaze at the moon through a handheld telescope reveals the scars of these cosmic confrontations. While Earth and its planetary companions gradually mend their wounds through the forces of wind, water, and erosion, the moon stands as a testament to the nearly flawless preservation of ancient craters on its airless surface. During the early years of the solar system, an eventful era known as the heavy bombardment period, Earth and the celestial bodies surrounding it witnessed massive impacts. However, Earth has experienced significant impacts only relatively recently in geological time. A colossal asteroid, approximately 6 miles wide, collided with Earth during the KT impact event on the Yucatan Peninsula some 65 million years ago. This impact unleashed a hot debris firestorm, causing massive fires and suffocating numerous life forms. An event of lesser magnitude occurred in 1908 along the Tunguska River in Siberia, where a smaller air blast managed to topple 60 million trees across an area of about 1,330 square miles. The potential devastation would have been catastrophic had the explosion occurred near a densely populated metropolis. Despite the removal of much inter-orbital debris in the early stages of our solar system, a considerable number of near-Earth objects persist in space. Occasionally, Mother Nature hurls these celestial boulders towards our planet. Interestingly, the likelihood of smaller objects impacting Earth is greater, given their more substantial population compared to larger counterparts. Astronomers, armed with data on near-Earth objects, orbital dynamics, explosions in Earth's upper atmosphere, and catastrophic extinctions, can discern the frequency of Earth's encounters. Satellites capturing the heat released during the entry of these objects into Earth's atmosphere have been providing valuable information over the years. Over the past 30 years, meteoroids exploding in Earth's atmosphere have caused at least one 5-kiloton explosion annually. Scientists now predict that over the next million years, Earth will experience impacts from objects approximately 300 meters wide. Additionally, 2 objects with a width of 0.6 miles are anticipated to strike during the same period. These larger objects pose a significant threat to civilization, reminiscent of the KT impactor that altered Earth's history and posed a potential threat to civilization. According to renowned astrophysicist Neil deGrasse Tyson, to comprehend the impending collision of an asteroid with Earth, it is essential to grasp the nature of asteroids. He describes asteroids as remnants from the early days of our solar system, resembling rocky fragments left behind during its formation billions of years ago. They are as space debris, irregularly shaped and floating across the vastness of the cosmos. These rocky objects, found predominantly in the asteroid belt situated between Mars and Jupiter, exhibit a diverse range of sizes, ranging from minuscule pebbles to colossal rocks spanning hundreds of miles. Unlike planets with their round and smooth surfaces shaped by gravity, asteroids lack sufficient gravitational force to mold themselves into perfect spheres. The prevailing belief has always been that asteroids are remnants of the cosmic dust and gas cloud that coalesced to form our solar system nearly 5 billion years ago. deGrasse further explains that when gravity orchestrated the formation of the Sun and planets from this celestial cloud, some materials resisted incorporation and persisted as smaller, leftover pieces, eventually recognized as asteroids. These asteroids also come in various types based on their composition. The first category includes carbonaceous asteroids, the most prevalent and rich in carbon and organic molecules. They hold the potential to unravel clues about the origins of life. Another type, silicate asteroids, mirrors Earth's rocky crust, often housing metal deposits like iron and nickel. Additionally, there are the metallic asteroids, rare formations composed mainly of iron and nickel, resembling colossal chunks of spacecraft hulls. While certain asteroids adhere to predictable orbits and pose minimal threats, others follow trajectories that could intersect with Earth's orbit, earning them the designation of near-Earth objects. Now, astronomers have continued to actively monitor these NEOs, evaluating the potential risks of impact and devising strategies for deflection if necessary. Asteroids and their destructive potential. Astronomers at NASA have now identified that the destructive potential of a rock is directly linked to its size when it collides with Earth. Every few million years, a 0.6-meter-wide boulder can unleash a colossal impact equivalent to 20,000 megatons of TNT. Similarly, an asteroid measuring just 300 feet in diameter has the capability to cause a 20-megaton explosion roughly every 1,000 years. To put it simply, there is a 1 in 10 chance that a 10-megaton impact, similar to the historic Tunguska event, might occur somewhere on Earth within the lifespan of an individual reaching 100 years. However, the risk of harm from such occurrences is significantly reduced by a factor of 50,000 or more, as the asteroid would need to strike in close proximity. The real challenge arises in detecting near-Earth objects, NEOs, determining their orbits, and predicting potential impacts. Looking ahead, scientists now predict that around 23 years from now, there is a noteworthy event that'd occur on Valentine's Day in 2046. There's a probability that Earth could encounter an asteroid larger than 150 feet in diameter. This celestial body, comparable in size to an Olympic swimming pool or a football pitch, may come within NASA's estimated diameter of approximately 160 feet. On that day in 2046, the asteroid is projected to make its closest approach to Earth, passing by more than 1.1 million miles according to NASA's data. Although the chances of an impact seem low, it remains a possibility. One such asteroid that has garnered attention is 2023 DW. Due to its size and visibility, it has been included in both NASA's and ESA's risk lists for potential impacts on Earth. NASA suggests that an asteroid of this size, ranging from over 80 feet to less than 3,280 feet, could potentially cause local damage to the impact area. The uncertainty surrounding such celestial events adds a layer of intrigue and underscores the importance of continued efforts to monitor and understand these space-borne risks. The impending catastrophe. Scientists and astronomers alike have always wondered why asteroids hold such significance. Well, experts have since found them to be like celestial time capsules, safeguarding ancient materials that played a crucial role in shaping our solar system. Their study has also been found to offer profound insights into the intricate processes behind the formation of planets and the emergence of life. Moreover, they harbor the potential to serve as invaluable resources for our future endeavors. Rich in minerals and water ice, asteroids could become vital assets for space exploration and even colonization. But then, there's the intriguing case of a colossal 370-meter-wide asteroid that has been circling Earth for decades. Scientists have accumulated compelling evidence hinting at the possibility of a collision, and the repercussions, they warn, could be catastrophic. While multiple events would need to align for the asteroid to strike Earth, the potential consequences are dire. Should such an impact occur, a substantial portion of the North American continent would face destruction. This celestial behemoth, known as Apus 99942, has long been categorized as a near-Earth space rock. In December 2004, it briefly stirred panic among scientists when initial estimations suggested a 3% chance of it colliding with Earth in 2029. However, subsequent studies, conducted with more time and precision, revealed that Apus 99942 would instead pass through a gravitational keyhole, a small region in space altering an object's gravity. This discovery shifted the anticipated impact date to April 13, 2036. Although the likelihood of a 2036 impact has been deemed almost impossible, scientists are now turning their attention to the year 2068, with a minute 1 in 150,000 chance of a collision. While Apus may never directly strike Earth's surface, renowned astrophysicist and author Neil deGrasse Tyson shared a chilling perspective on the potential aftermath. During a university lecture in 2008, Tyson highlighted that if the asteroid were to collide with Earth, the ensuing damage could be horrific, potentially leading to the obliteration of the entire west coast of North America. And in this age of exploring the universe through advanced technology, the celestial event we're about to witness is considered one of the most significant occurrences. According to experts, accurately predicting the path of this cosmic phenomenon proves challenging due to the inherent difficulty in measuring such celestial bodies. While assuring the public that the celestial object won't collide with Earth, scientists admit uncertainties about its exact trajectory. However, they identify a critical zone, known as the keyhole, spanning a 600-mile range. This keyhole hence becomes a crucial factor, as passing through its center could potentially result in a collision with Earth approximately 13 years later. Initially thought to be around 600 miles wide, recent investigations have refined this estimate to just over 300 meters. The reduced size of the keyhole raises concerns, as it leaves minimal room for the celestial object to navigate through without triggering catastrophic consequences. deGrasse Tyson, in another of his captivating speeches, emphasized the significance of April 12, 2029, as the date when humanity would learn whether the celestial object would navigate the keyhole unscathed. In the worst-case scenario, if the object were to pass through the narrow keyhole, the Earth could face a devastating impact, exacerbated by the object's accelerated speed upon entering our atmosphere, potentially causing a tsunami. Despite the alarming information presented during Tyson's lecture, subsequent studies by scientists challenged the likelihood of the celestial object, named Apus, successfully passing through the tiny keyhole. NASA, in 2008, reassured the public by stating the chances of Apus colliding with Earth in 2036 were a mere 1 in 45,000. And by February 2014, the Jet Propulsion Laboratory's Sentry Risk Table further reduced the odds to an even more reassuring 1 in 150,000 for the anticipated impact date of April 12, 2018. The Yarkovsky Effect Predictions. Back in December 2004, there was a noteworthy event related to an asteroid. Initial observations sparked concerns, indicating a 2.7% probability that this celestial body might collide with Earth on April 13, 2029. As subsequent observations unfolded, the predictions improved, ultimately ruling out any impact in 2029. However, until 2006, a lingering uncertainty persisted. There was a slim chance that during its close encounter with Earth in 2029, the asteroid, named Apus, could pass through a gravitational keyhole, measuring no more than about 800 kilometers in diameter. This hypothetical scenario could set the stage for a future impact exactly 7 years later on April 13, 2036. This intriguing possibility placed Apus at level 1 on the Torino Impact Hazard Scale. It wasn't until August 2006 that the likelihood of Apus passing through the keyhole was deemed very small, leading to a downgrade of its Torino scale rating to 0 by 2008. During the peak of concern, on December 27, 2004, Apus reached an unprecedented level 4 on the Torino scale. Further alleviating worries, preliminary observations by the Goldstone radar in January 2013 effectively dismissed the possibility of Apus colliding with Earth in 2036. By May 6, 2013, any chance of an impact on April 13, 2036 had been entirely ruled out. Fast forward to March 2021, and Apus was overshadowed by 6 other asteroids, each having a more significant cumulative Palermo technical impact hazard scale. Moreover, none of these contenders had a Torino level above 0. To add a cosmic perspective, an asteroid roughly the size of Apus, around 307 meters, is expected to impact Earth approximately once every 880,000 years on average. Confirming the safety of our celestial neighborhood, observations in 2020 by the Subaru telescope supported David Vui's 2015 Yarkovsky effect predictions, putting any concerns about Apus to rest. The Goldstone radar diligently observed the celestial object known as Apus during the period from March 3rd to March 11th, 2021. This meticulous observation significantly contributed to the refinement of Apus's orbit. Subsequently, on March 25, 2021, the Jet Propulsion Laboratory made a noteworthy announcement, assuring that Apus poses no threat of impacting Earth within the next century. The precision of these observations played a crucial role in narrowing down the uncertainties related to Apus's approach in 2029. Previously spanning hundreds of kilometers, the margin of uncertainty has now been remarkably reduced to just a couple of kilometers. This improvement has greatly enhanced our ability to predict Apus's future approaches. According to the Sentry Risk Table, the estimated kinetic energy Apus would bring upon impact with Earth is equivalent to a staggering 12,200 megatons of TNT. To put this into perspective, the impact that led to the mass extinction event, responsible for the demise of dinosaurs, released about as much energy as 100 million megatons, or approximately 100 teratons. It is crucial to recognize that the potential consequences of an impact would vary based on factors such as the composition of the asteroid, its impact location, and the angle of impact. In 2008, the B612 Foundation conducted estimations concerning the trajectory of Apus in the event of a potential Earth impact in 2036. These ongoing efforts in celestial observation and risk assessment aim to enhance our understanding and preparedness for any potential celestial threat. While an impact could cause severe damage to an area spanning thousands of square kilometers, the likelihood of triggering long-lasting global effects, such as an impact winter, is deemed improbable. Asteroid Bennu and its likely collision with Earth. NASA's astronomers are currently tracking an asteroid named Bennu, and their calculations suggest that this celestial object could pose a threat to Earth, impacting an area comparable to the size of Texas. Bennu has been under scrutiny since its discovery in September 1999, making close approaches to Earth approximately every 6 years, notably in 1999, 2005, and 2011. Scientists are particularly concerned about Bennu's potential to enter a gravity keyhole, a trajectory that could set it on a collision course with Earth in the year 2182. A critical flyby in 2135 will play a decisive role in assessing the likelihood of a collision, with odds currently estimated at 1 in 2,700. Measuring about 3 city blocks wide and boasting a diameter of 1/3 of a mile, Bennu holds the potential to exert significant influence over an area as vast as Texas. In contrast, the asteroid responsible for the extinction of dinosaurs 65 million years ago was a colossal 6 miles wide, with a destructive force equivalent to 10 billion atomic bombs. This ancient asteroid caused widespread devastation, generating tsunamis, blocking sunlight, and triggering wildfires. Our planet's history is marked by impact craters, such as the Vredefort crater in South Africa, formed by an asteroid impact approximately 2,023 million years ago, and the Chesapeake crater in the United States, believed to result from an asteroid strike around 35 million years ago. The largest impact crater in Asia, the Papagaï crater in Russia, was created approximately 35.7 million years ago by an asteroid with a diameter of about 5 miles. And despite Bennu's comparatively small size, a potential impact could release an astonishing 1,200 megatons of energy, surpassing the destructive power of any human-made nuclear bomb by 24 times. Now, this raises an important question. Can we develop strategies to prevent Earth's destruction from a future asteroid impact? The path of risk. In an endeavor to devise effective strategies for diverting potential celestial threats, a distinctive corridor was conceptualized, aptly named the path of risk. This narrow pathway, spanning a few kilometers, traverses southern Russia, stretches across the North Pacific in close proximity to the coastlines of California and Mexico, weaves between Nicaragua and Costa Rica, crosses northern Colombia and Venezuela, and culminates in the Atlantic just before the shores of Africa. Employing the advanced computer simulation tool NEOI, an assessment was conducted, revealing that the hypothetical impact of a celestial object, like Apus, along this path of risk, could result in staggering casualties, exceeding 10 million in countries such as Colombia and Venezuela. Delving further into the potential consequences, a deep water impact in the Atlantic or Pacific Oceans was anticipated to generate an incoherent short-range tsunami capable of causing devastation within a radius of approximately 1,000 kilometers for most of North America, Brazil, and Africa, 3,000 kilometers for Japan, and a substantial 4,500 kilometers for certain areas in Hawaii. Various organizations, including NASA, the European Space Agency, and the Planetary Society, along with research groups, proposed diverse strategies for deflecting Apus or similar celestial objects. These strategies encompassed gravitational tractor methods, kinetic impact solutions, and even the deployment of nuclear bomb techniques. Highlighting the global concern, Anatoly Perminov, the director of the Russian Federal Space Agency, expressed intentions to explore designs for a potential deflection mission to Apus. Similarly, on August 16, 2011, researchers at China's Tsinghua University envisioned a mission involving an impactor spacecraft to redirect Apus onto a safer trajectory. Interestingly, this spacecraft would be steered and powered by a solar sail, operating in a retrograde orbit, offering an alternative approach to altering the asteroid's course and averting the gravitational keyhole during its resonant return to Earth. On February 15, 2016, Sabitsa Garayev, associated with the Makiy Rocket Design Bureau, made an intriguing announcement about utilizing Russian intercontinental ballistic missiles, ICBMs, to target relatively small objects near Earth. The focus of this initiative was revealed to be objects ranging from 20 to 50 meters in size. Notably, the renowned celestial body 99942 Apus was identified as a potential subject for testing within this program. Fast forward to October 2022, a novel approach was proposed to address the challenge of potentially hazardous asteroids like 99942 Apus. The proposal involved mapping the interior of these celestial bodies to identify the optimal impact zone. While the likelihood of a direct collision between Apus and Earth has been downplayed, the cosmos remains teeming with thousands, if not millions, of other asteroids that traverse space annually, skimming perilously close to our planet. Throughout history, instances of asteroids colliding with Earth have been documented, leading to catastrophic consequences such as the extinction event that wiped out the dinosaurs. The risk of injuries and significant impacts on our planet persists, underscoring the importance of continued exploration and preparation for potential cosmic encounters. Now it's time for today's subscriber pick. This NASA satellite just detected something massive between Earth and planet Venus. In the vast expanse of space, where the cosmos whispers celestial secrets, a NASA satellite named Celestial Sentinel floated silently between Earth and the enigmatic planet Venus. Its mission was to unravel the cosmic mysteries that veiled the universe. And one fateful day, it detected something colossal, something that sent shockwaves through the scientific community. Dr. Olivia Turner, a brilliant astrophysicist, was the first to receive the transmission. As she peered into the data streaming across her monitor, her eyes widened with disbelief. The satellite had picked up an anomalous signal, a pulsating energy that seemed to emanate from the space between Earth and Venus. It was a cosmic heartbeat, resonating with a frequency that defied all known laws of physics. With a sense of urgency, Dr. Turner alerted her colleagues at NASA, and soon the entire scientific community was abuzz with excitement and fear. The phenomenon was dubbed the Celestial Echo. NASA, in collaboration with international space agencies, launched a daring mission to investigate the source of the Celestial Echo. The spacecraft, named Stellar Voyager, embarked on a journey through the cosmic void, carrying a team of elite scientists led by Dr. Olivia Turner herself. As Stellar Voyager approached the mysterious anomaly, the crew witnessed awe-inspiring celestial phenomena. Streams of radiant energy danced in the darkness, creating mesmerizing cosmic auroras. The pulsations of the celestial echo grew stronger, resonating with the very fabric of space-time. As the crew absorbed the profound knowledge bestowed upon them, they realized that the celestial echo was not a threat, but a cosmic symphony, a harmonious vibration that connected all life in the cosmos. The entity, a guardian of cosmic balance, had chosen to reveal itself to humanity in a moment of transcendence. The crew returned to Earth, forever changed by their encounter with the celestial being. What are your thoughts on this cosmic odyssey you just saw on your screen? Let us know your opinions in the comments below. The Comet Leonard. There have also been speculations that the massive object passing through our blue planet and the planet Venus could be nothing more than a supergiant comet. When Comet Leonard, a celestial body composed of rock and ice and measuring approximately half a mile or 1 kilometer in width, made its closest approach on January 3, 2022, it marked the culmination of a remarkable 40,000-year journey. Some experts are now of the opinion that this massive object could be Comet Leonard, attempting to make a re-entrance into Earth's atmosphere and coming closer to our blue planet than it ever has. But prior to this significant encounter in 2022, 2 solar observatories had previously captured captivating images of the comet, showcasing subtle changes in its appearance and highlighting the development of Leonard's impressive iron tail. A stream of ionized gases could be seen emanating from the comet's nucleus, growing longer and brighter as the observation progressed. During this celestial event, NASA captured something peculiar between Earth and Venus. Observers online similarly noticed the emergence of a large, shield-like object, seemingly forming during Comet Leonard's closest approach. The stereo-head H2 camera was responsible for documenting this intriguing footage, revealing a substantial structure appearing between Earth and Venus. On the screen, Venus was positioned to the left, Earth to the right, and as Comet Leonard swept by Earth, the large object materialized, resembling a protective shield that, according to some, intercepted part of the comet's tail from reaching Earth. What adds to the mystery is that this shield-like object only becomes visible when Comet Leonard is in view, aligning itself with Earth. Some speculate that it appears as if this object is safeguarding Earth from the comet's potential space debris. Notably, this is not the first time such an anomaly has been detected. In 2020, the stereo camera captured a similar object on March 12th while observing the Lagoon Nebula alongside Venus and Earth. In that instance, viewers noted the artifact's resemblance to a large will and suggested it might be emitting a protective beam, reinforcing the idea that something substantial may be shielding Earth from space debris. The footage, obtained directly from NASA by a telescope aboard the Ruby spacecraft, is particularly intriguing due to its official source. These space probes, strategically positioned on either side of the Sun, play a crucial role for NASA and scientists in comprehending the inner workings of the solar system. They provide valuable insights, especially when it comes to observing celestial bodies that come into close proximity to Earth. But could these new objects recently picked up by NASA's satellite be Comet Leonard or any of her sister comets? Experts say it's a great possibility, and the chances are. Preparing for an asteroid's impact. Experts have warned that while preparing for the potential impact of an asteroid might seem like a mere theoretical exercise, it's anything but that. Contrary to what one might think, there has been a noticeable decline in the frequency of asteroid collisions in our solar system compared to earlier eras. However, this doesn't eliminate the possibility of an asteroid crashing into Earth entirely. The timing is crucial, and rallying people together to prepare for such an event is as challenging as attempting to predict when it might occur. Unlike relying on mere thoughts and prayers, taking action is imperative. Even a seemingly small asteroid with a diameter of just 0.33 meters can unleash a devastating force upon impact, releasing nearly 10 gigatons of energy. Imagine a crater 6 meters across and 2,300 feet deep, along with the release of 1 cubic mile of ejecta, flash-heated and sent into the atmosphere. As it rains down, it could initiate firestorms on land. Alternatively, if the asteroid were to strike the ocean, the threat of massive tsunamis would loom large. Numerous asteroids larger than 0.3 miles exist, and regardless of their size, the trajectory of human civilization would be irreversibly altered. In essence, we would find ourselves in a precarious situation, similar to our ancient ancestors. Survivors, if any, would face a battle for their lives. The community dedicated to studying asteroids is well aware of the danger posed by these celestial bodies. As such, scientists and politicians alike gathered at the Planetary Defense Conference in 2023 to delve into various aspects of potential asteroid strikes. And now that the conference has been concluded, a meticulous examination of our response is underway, extending beyond the scientific and technological realms. Given the intricacies of asteroid analysis, experts are now meticulously considering the legal frameworks established on an international scale for such an eventuality. Similarly, they're actively understudying the practices of various states in multilateral forums and weighing the scholarly opinions available. But what sets asteroid impacts apart from other natural disasters is their distinct nature. They offer a unique advantage of anticipation, enabling us to take precautionary measures. The foundation of the conference was based upon a captivating premise. An asteroid measuring 0.3 miles in diameter is hurtling towards Earth. Although this particular celestial body was discovered in January, its elusive orbit posed challenges for detection. Consequently, the Planetary Defense Center (PDC) classified it as a potentially hazardous asteroid, giving it the name 2023 PDC. As attendees delved into their discussions, a shared realization emerged. The likelihood of 2023 PDC colliding with Earth surged with each subsequent observation. In a collaborative effort, attendees embarked on calculations and made even more startling revelations. Most notably, they found that the asteroid would collide with Earth in October 2036, affording humanity a seemingly comfortable 12-year window. Theoretically, this span promised an ideal opportunity to unravel the mysteries surrounding the asteroid's composition, potentially dispatching a spacecraft for a close investigation. The extensive lead time, while advantageous, unveiled its own set of challenges. Once the exact location of the impending impact was pinpointed, a cascade of concerns emerged. The region, now aware of its impending fate, would immediately get plunged into a state of chaos. Questions regarding mass evacuation and sheltering arrangements surfaced, alongside the looming threat of economic collapse, bankruptcy, and a halt in essential production. The prospect of societal breakdown loomed large, as the populace would expectedly become gripped with panic. Attempts to escape the inevitable catastrophe were anticipated, raising alarming questions about the stability of the rule of law. The scenario painted the grim picture of an unpredictable and tumultuous period where war, cults, fascist dictators, and other manifestations of humanity's darker instincts could emerge. Echoes of historical patterns seemed to be clearly on the horizon, even before the asteroid threat entered our collective consciousness. And in a world where chaos and disorder loom large, humanity's very existence is greatly threatened. But even in the face of anarchy, there are always individuals who dedicate themselves to preparing for the worst-case scenarios. And such is the case when considering the potential impact of an asteroid. Back in 2011, as the ominous possibility of an asteroid strike became apparent, the United Nations Committee on the Peaceful Uses of Outer Space took decisive action. The Action Team on Near-Earth Objects was established, bringing together governments from around the world. This marked the initiation of a concerted global effort to formulate a strategy in response to the looming threat. This collaborative endeavor was not confined to mere discussions. It sparked the formation of additional committees. Their collective aim was clear: develop strategies to not only detect potentially hazardous asteroids, but also to implement measures to divert them if necessary. The ensuing years witnessed the unfolding of a multifaceted approach, blending technology and scientific prowess. It also kick-started the planetary defense missions, a testament to our collective commitment to safeguarding our existence. Efforts were intensified to identify all potentially hazardous asteroids, with initiatives like NASA's Double Asteroid Redirection Test, DART, taking center stage. These missions, while sounding like scenes from a sci-fi blockbuster, were very much a reality as governments and organizations worked tirelessly to refine strategies and bolster our planetary defenses. So, the danger of asteroid strikes is not an unfamiliar concept. However, these elaborate networks of initiatives, from detection to deflection, reflect our collective determination as a human race to face the unknown and secure our future against celestial threats. Thanks for watching, and we'll see you in the next one.